Here it is an important question. Is quasi-static a reversible process? This question can also be asked the other way, like, is a reversible process a quasi-static process? So let's first understand what is quasi-static. Quasi-static is a almost stationary process. That means it is a slow process in which two neighboring states are almost in equilibrium with each other. Okay, so what is reversible? A reversible is something which the process, if the process is or can be proceed in reverse direction, then we say it is a reversible process. Also there are some other things we'll discuss, but today we are going to deal with this question: is quasi-static a reversible process, or is a reversible process a quasi-static process? So here it is written, all reversible processes are quasi-static processes. How is it so? See, if you see any reversible process, in this process you can see that two neighboring states like this one and this one, they have same property. It almost makes a rectangle. This almost makes a rectangle. Why? Because this pressure is same between two neighboring states. Why? Because they are in equilibrium with each other. So that is how we can say that any reversible process has to be slow, right? If there is any reversible process, it will be very slow. And when it is slow, we can also tell or name it as quasi-static process, because quasi-static process is also slow process in which neighboring states are in equilibrium with each other. Next, this question that we have just said, is quasi-static a reversible process? Not always. Why? Because if you just draw any PV diagram and let's say this is 1 to 2 forward process and this is 2 to 1 reverse process. So in quasi-static process, what happens is that you do not get your properties regained, right? The properties of the system cannot be regained in quasi-static process. Why? Because it is irreversible in nature. It has some effect on the surrounding. It leaves some effect on the surrounding and by various means like dissipation of energy or friction. So this is why you cannot regain the properties of the system like you had P1, V1, T1, pressure, volume, temperature of the system. But now if you just reverse the process, you cannot get the same properties. Why? Because quasi-static is irreversible in nature. So there will be some loss, some frictional loss, some heat dissipation or some energy dissipation to the surrounding. So that is why we cannot say that all the quasi-static processes are reversible processes, because quasi-static has some effect on surrounding, whereas reversible process is something which is ideal process. It says that when 1 to 2 process is followed, then 2 to 1 process can be followed in reverse direction and the properties of the system will be same as that of initial one. So you can regain all the properties like P1 pressure, V1 volume and T1 temperature. You can regain all these properties by following the reverse path. But in quasi-static, when you follow a reverse path, then you cannot get that same point back, because there is some heat dissipation that has gone to in 1 to 2 during 1 to 2 process, and also there is some heat dissipation in a backward process also. Now you might have understood that any reversible process, if you see, it is very slow, therefore you can also name it as quasi-static. But any quasi-static process, if you see, it has some effect on surrounding, therefore you cannot name it as reversible process, because reversible process does not leave any effect on surrounding. Therefore you can also say that any reversible process is if you eliminate the frictional and other dissipative forces from the quasi-static process, then that will be reversible process.